Okay, hello. Hope everybody's doing good. I have a final version of my VSoL, Variable Speed of Light draft. It's already uploaded. It'll be live within a couple of days, maybe. So, let me see what we're going to do. Okay. See what we do here. Add to the screen. And I'll go ahead and where am I going? There. Like this. Oh, I forgot, I gotta mute myself.
Abstract. Ever since I can remember, the message was drilled into our minds as students that the speed of light is constant in a vacuum and in outer space. Why such a big deal? It has been a matter of way too much emphasis for way too many years, obscuring the reality. It's time to move into a greater understanding. To be certain, the speed of light is always 186,000 miles, about 299,792,458 kilometers per second in every single case. As if the parameters to measure the speed of light are constant too. Another thing for certain is that light bends in outer space in situations where there is gravitational lensing. The lens effect is when light is slowed down in one area more than it is slowed down in the outlying areas. The result is a magnifying effect of space itself. Isn't that neat? Wait. What? Light is slowed down? Yes, that's what gravitational lensing is. That's what a lens does. The light that is slowed down is bent less, while the light that is bent more is faster. Still, light always travels at a constant speed mathematically, right? It seems like a contradiction, and it is. The speed of light being constant is an error-filled mathematical construct. The measures of time and distance to measure light speed change, so the math is incomplete. It's not the whole story of what is happening, because it's the parameters to measure time and distance that change which are not even being considered in the equation. Our observations often give us the impression that light is traveling at different speeds when observed over great distances from one galaxy to another, and as a matter of fact, it's not an illusion. Light does indeed travel at different speeds depending on the amount of gravity in the vicinity. Hence gravitational lensing and superluminal motion, which moves faster, and the outer spiral arms of galaxies, because everything including light is moving faster the farther away from the center of the galaxy it is. Keywords: cosmology, physics, light, speed, time, distance, measure, science, general relativity. The variable speed of light. This booklet is not intended to be a heavy or hard to understand science textbook. It's everything you always ever wanted to know about light speed but didn't know to ask because you were not properly informed about the properties of spacetime and light speed to begin with. Most of what I am saying here is or should be basic common knowledge that everyone should already know. The only way this content will be hard to understand is if you have never kept up with the most basic aspects of physics and general relativity. Here are the basics of general relativity. Gravity affects the rate of time and the measure of distance. This is significant. The more gravity there is, the more the measures of distance are shortened, and the slower time passes by. Conversely, the less gravity there is, the more distance is expanded or inflated, not inflating, and the faster time passes by. It's simple, right? Well, the speed that things move through space complicates things a little, but we don't need to go there yet. For the time being, we are only considering general relativity and our perception of the speed of light. In technical terms, everything is accelerating, so everything is under the influence of gravity, but to what extent is this true? How much does gravity influence things in deep outer space where there's no mass and no galaxies? What about the places called the Lagrange points between galaxies? These are places where things can remain relatively fixed in space, where they don't have much acceleration, but still, everything is moving through space, so everything is under the influence of gravity to some extent, the caveat being unless there is a significant Lagrange point basically canceling out gravity for all practical purposes. The important thing to remember is that not everything is experiencing the same amount of gravity, considering that gravity drops off exponentially outside of a galaxy. This means the effects of gravity drop off considerably, which means a lot, outside of a galaxy. However, the effects of gravity do not change the measures of time and distance much locally where we are. Locally, the effect is quite flat, the same as the Earth looks flat locally. When we look at a cat or a dog, we don't see any changes in the rate of time or in the measure of distance. The gravitational waves detected by LIGO interferometers are so small that extremely sophisticated measuring equipment and instruments are required to pick up the faint signal of the variation of distance locally. The variation of clocks in different places is more easily verified because of the precision and accuracy of clocks in recent times that has also been achieved. Still, the variation of the rates of time are also very insignificant locally. This is an affirmation that the speed of light doesn't change much locally. However, the speed of light does change considerably over great distances because the changes in the measures of time and distance compound the resulting effect of changing the speed of light significantly on a larger scale. It's what gravity does. It's what light does. It's observed. This is basic general relativity. More gravity slows down time. Less gravity allows time to speed up. More gravity shortens distance. Less gravity allows the same measure of distance to increase in size. Again, these changes in time and distance compound changes in the speed of light so that the changes are greatly exaggerated over great distances. Observations in space. No need to worry, there have been no observations of pigs in space as far as I am aware of, no cats or dogs either. The important thing to remember is that gravity in our universe is not flat over large distances. When we look at a galaxy, it's not like observing a cat here on Earth. Remember that a galaxy covers an enormous distance. It's not like looking at a yard bird that is fat in the middle. The measures of time and distance are not the same across the expanse of a galaxy. They aren't flat. Time and distance might seem constant or flat locally, but not over great distances. Other galaxies are very large and very far from us, and there is no matter or mass in our line of sight to slow down time or shorten distance. This means things happen fast and light is arriving fast. Often other galaxies have outer spiral arms that are rotating. This shouldn't be a problem, but it's been a concern for a long time now because the rotation of the outer spiral arms seems to be moving faster than expected for the amount of gravity in the galaxy, as if the gravity was constant throughout. This is very puzzling to many scientists. So much so that they even imagine dark matter to try to explain it. It's so obvious what the problem is when you do the thought experiments in general relativity. Dark matter isn't needed when the measures of time and distance change throughout the galaxy. Another mysterious observation in space is known as superluminal motion. This is when a galaxy sends a plasma jet shooting out in opposite directions from the poles of a spinning black hole in the center of a galaxy. The scientists were curious when studying this motion of ejected plasma, so they measured the velocity of this mysterious light stream, and they actually published a paper documenting the velocity as being 7 times the speed of light. This actually happened. This is a real problem since nothing ever exceeds the speed of light, not even light itself, not even once. I'm from the Amazon jungle and it's clear to me what is happening. It's so obvious when you do the thought experiments in general relativity. There's another small problem with the Voyager spacecraft that are ironically, or predictably, losing their orientation as they are leaving the solar system. It might not seem like a very big deal except they didn't even announce this momentous occasion of leaving the solar system until several years after the fact. It seems to me like the measures of time and distance are causing problems there as well. They claimed that the spacecraft were sending back erroneous data, so they uploaded new computer information to try to correct what they say was the problem since according to them, it wasn't able to determine where it was. They said the data was gibberish. I'm from the Amazon jungle and I have been waiting on the edge of my seat for several years for updates on the progress of the Voyager spacecraft, expecting to hear notifications about these kinds of anomalies. So, what did they do? They delayed giving us the results for several years since the results were not what they were expecting. It's like when the archaeologists tested the Y chromosome of King Tut and didn't publish the results because the results were not what they wanted. They didn't want King Tut to have a European origin of R1b. Someone else in Europe had to publish the results. The explanation for the variable speed of light is simple. It can't be that hard. Remember when looking at a galaxy that it's not like looking at a cat, but if the galaxy was a cat, it would be very thin in the middle and its outer extremities would be much larger, increasing in size with distance from the middle and moving around surprisingly fast around the outer edges. Why? It's because the measures of time and distance are not the same throughout the galaxy. The farther away from the center of the galaxy it is, the faster time passes by and the greater the measure of distance is, compounding the change in the speed of light and the motion of things. Maybe if they measured the cat's tail, it would be moving several times faster than the speed of light too. Oh yeah, there are no cats in space, but if there were, it's probably what they would be saying. Can you see what the problem with the superluminal motion is? To be fair, additional papers that came out about it suggested that it was all just an illusion. They say something made it look like the plasma jet, which is matter, was moving 7 times the speed of light, something like a mirage. They suggested that the combined speed of the motion of the train of plasma together with the actual speed of light made it appear to double its speed when it was only traveling near the speed of light. Wait a minute, hold on a second. Doubling the speed of light isn't 7 times the speed of light. I was sure that if you sent a light beam from a moving train, the speed of light would still be the same anyway, even light from a moving train. Or maybe it was spitting out spacetime along with the plasma, which would require a lot of force, which would drop off exponentially outside of the galaxy. In any event, this was quite the re-evaluation that was made of the event. They went from saying it was 7 times the speed of light to saying that it was not even the speed of light. Obviously, someone is not considering the differing measures of time and distance over great distances the farther away it is from the center of a galaxy. It is compounding the changing of the speed of light as observed by us from where we are with a somewhat fixed rate of time and distance. So, let's do a thought experiment. say 1001 out loud. That is about 1 second. Now say the same phrase, 1001, as fast as you can. You just demonstrated the dilation of time, where time goes by faster the farther away it is from the center of the galaxy. Now let's say that a yardstick is taken from Earth to somewhere farther away from the center of our Sagittarius A black hole than where we are, so that when you compare the length of the yardstick, now the same stretched yardstick is the equivalent of 10 yardsticks back on Earth, but it's still the same yardstick in its new location where there is significantly less gravity. That is distance dilation. So, now put your hands about a foot apart, representing 186,000 miles, about 299,792,458 kilometers, while saying 1001, and pretend to see a photon traveling from one hand to the other while turning your head following the imaginary photon as you are saying it. That is the constant speed of light, c. Then spread your hands far apart, still representing 186,000 miles, while saying 1001 as fast as you can, representing 1 second, while pretending to see a photon in this single frame of reference going from one hand to the other while turning your head again following the imaginary photon as you are saying that. Do you see the difference in speed? Don't get lost. The second is still 1 second mathematically, right? But it's really not the same measure of time, and the distance between your hands is still 186,000 miles, right? But it's really not the same measure of distance. The photon is still traveling at the speed of light, c. Right? It's just that the same reference of time is sped up and the same reference of distance is expanded. So, tell me whether the speed of light changed. Did the imaginary photon travel faster the second time you did the thought experiment? Yes. It did. The speed of light absolutely did change its speed as observed by us with our fixed measures of time and distance. This is what is happening everywhere over great distances in deep outer space on a continual basis. The distance is not as far as it appears to be outside of the galaxy because it is expanded distance, and the time is passing by faster, both of which compound the change in the actual speed of light as perceived by us from where we are with our slower rate of time and our shortened measure of distance. It's not that anything is moving 7 times the speed of light. Superluminal motion is literally a way to better calibrate the rates of time and the measures of distance outside of the galaxies. Our observations should be what are guiding us, instead of trying to hide the obvious elephant evidence under the rug where you think no one can see what is happening. Sometimes people make me think I'm smart, and I know that isn't the case. I'm as slow as most of the rest of you. I just simply did the thought experiments and carried them out to the full extent. It's not that hard to understand. Just repeat the thought experiment outlined above and you can visualize the speed of light changing along with the measures of time and distance that are changing due to the effects of general relativity and less matter or mass and gravity in the vicinity of our line of sight between galaxies. This is not a new phenomenon or a new discovery. It is just plain general relativity carried out in deep outer space where there is no matter to slow down time or to shorten distance. If it means all the calculations of superluminal motion and the spiral arms of galaxies are way off, so be it. What is there to be afraid of? A young Earth? The universe doesn't care. Gravity drops off exponentially outside of galaxies, as does the effects of gravity. There is no single age of the universe. Because of general relativity, clocks run at different speeds. This is a known fact, and it means that there is no single rate of time or age to the universe, since time in the universe is a fabrication to begin with and time throughout the universe is passing by at all different speeds. General relativity is an observation and not something that can be questioned anymore. The accuracy of our clocks running at different rates depending on where they are in interferometers that detect gravitational waves, which is the dilation of distance, have confirmed general relativity once and for all. This means that the universe is both very old and very young at the very same time in the very same universe depending on where it is in the universe. Time itself is a real fabrication that is the result of the amount of matter and mass in the vicinity. It's the existence of matter and mass that slows down time and shortens distance. There is no single measure of distance in the universe. The variation of distance has been confirmed for the first time in history by the collision of 2 neutron stars called a kilonova, where they were able to see or detect both the gravitational waves with interferometers and the simultaneous explosion produced by the kilonova as seen with telescopes. They were also able to detect the formation of heavy metals from this event. This is one of the recent greatest discoveries in human history. The collision of black holes hasn't been seen with telescopes as the kilonova was. Needless to say, the detection of a kilonova with interferometers was one of the greatest discoveries ever achieved by humans. Because of general relativity, a yardstick is never the same size unless the amount of gravity is the same. We aren't able to see this effect locally where we are, since the distances we are seeing on Earth aren't very great. Locally, the Earth also appears to be very flat. A greater perspective from greater distances shows that the Earth is not flat. It's very round instead, which is a huge difference. The same is true for the measures of distance. For all we know, a yardstick when taken outside of the galaxy could be 10 times the size of our yardsticks on Earth, especially in the Lagrange point between galaxies. Some are even saying that the distant galaxies seen by the JWST are 10 times as large as expected, which probably means that they aren't as far away as what they seem to be. This expanded distance might not have the effect that you are thinking of though. It doesn't mean that the distance in deep outer space is greater, it means the distance is less distant. With expanded distance there will not be as many frames of reference of 186,000 miles between us and distant galaxies, making them less distant. The distance in the outer spiral arms is less distant than they appear to be from where we are. The distance spanning a galaxy on a flat plane is like a piece of pie with a singularity in the middle. It's the same distance in the outer rim of a slice of pie compared to the single point in the middle and everywhere in between on the slice of galaxy pie. The measure of distance keeps on increasing in size the farther away from the singularity that it is. Some things to consider in general relativity are that the radius of a black hole is greater than the circumference of a black hole, and the distance between us and the most distant galaxy ever detected by the JWST telescope is closer to us than the center of our own Milky Way's black hole. Things in deep outer space are not as they appear to us to be, and they are not as far away as they appear to be, and it's not like looking at our pets out in the yard. This is the effect of general relativity, which is now an observation, not just a theory. No need for dark matter. The motion of the galaxies is explained by general relativity alone. The movements away from the center of mass of the galaxy are compounded since the distance of the spiral arms isn't as far as it seems, and the time is passing by faster in the outer spiral arms of the galaxy, both together allowing for an observed faster speed. The same is true for superluminal motion. No, the plasma jets are not shooting out 7 times the speed of light. The distance is not as far as it appears to us to be, and the passing of time is faster so that things take place faster in the outermost parts of a galaxy. Academics don't seem to get it. I know they don't understand it because they never mention the compounding effect of the changing measures of time and distance that greatly alters the speed of light. No dark matter particle has ever been detected since they are imagined and don't exist. There is also no purple grape jelly on the far side of the moon or any other such imaginary things. A day is like 1,000 years, and 1,000 years is like a day. And a foot is like 1,000 miles, and 1,000 miles is like a foot, literally. Dark matter is nothing more than a fudge factor from not considering the effects general relativity has in deep outer space across large distances, and it's also an attempt to support inflation, while simultaneously forming galaxies, which is a universe expanding into oblivion for no reason. Speaking of which, no need for dark energy. Dark energy is the vacuum energy of space, which is the exact opposite of inflation. Suction is the opposite of inflation, and it is now closely associated with black holes. It has been found that black holes are growing whether they are drawing in more matter or not because their size is increased by drawing in spacetime alone. This is what I always thought was the cause of the vacuum energy ever since I was a kid. There is no need for any confusion. There are no imaginary inflatants, which is not even a word. There is no purple polka-dotted jelly sandwich eater on the far side of the moon either. The redshift is caused when light leaves a galaxy as there is less and less gravity. Blue shift occurs when light enters a galaxy where there is more and more gravity. Everything being equal, the light leaving a galaxy is first redshifted and then blue shifted back to its original spectrum as the light enters another galaxy. Obviously, all things are not equal when observing light from other galaxies. This results in both red-shifted light and blue-shifted light from the galaxies around us. It's not very complicated. Light from very distant galaxies is often more red-shifted since the light is passing by the mass of a number of other galaxies in order to reach us. This causes a redshift since there is more gravity from large masses outside our galaxy than there is from our galaxy. The farther away the galaxy is, the more gravity and masses that the light must pass by in order to reach us, so the more redshifted it is. Again, it's not that complicated. The good news is that the universe is not expanding into oblivion for no reason. Where would the energy be coming from for such a thing anyway? The variable speed of light. As stated previously, light always travels 186,000 miles, about 299,792,458 kilometers a second. If you haven't figured it out by now, it's the measures of time and distance that change. Time dilation and gravitational waves have now been confirmed so that they are literally observed. General relativity is no longer just a theory, it's the law of time and distance. This confirms absolutely that light speed changes. If general relativity is true, and it is, light speed depends on the amount of gravity there is in the vicinity. I don't think it takes a genius to understand this. When you change the parameters that light speed is determined by, you change the light speed. It turns out that the combined effect of both time and distance dilation greatly compounds the effect of changing the speed of light, which is entirely dependent on the amount of gravity in the vicinity. Light from distant galaxies only slows down when it encounters the gravity of another galaxy from the slower rate of time and the contracted measure of distance, which also causes gravitational lensing in some cases. Superluminal motion, that is said to be 7 times the speed of light, something which is totally impossible, and the spiral arms of galaxies moving faster than expected are both observations that are the result of the changes in time and distance, which also change the speed of light. It's what gravitational lensing is. A lens alters the speed of light. When the measures of time and distance change, the speed changes. Science teachers need to understand this. If I had a car with a variable speed transmission, it would change gear ratios without changing gears. It would be a similar effect if I was very strong and I could change the rate of time to go by faster, and if I could alter the measure of distance so that it is greater, my car would be seen to go even faster without ever changing the measured speed, because a mile is longer and an hour is shorter. That is what the variable speed of light is. If you don't see this, do the 1001 thought experiment I suggested earlier. Changing the measures of time and distance changes the speed of light. It's so simple. Every physics book dealing with the speed of light has to be corrected now. The speed of light is variable over great distances throughout the universe. It's called the variable speed of light, VSoL. The universe is not flat, the same as the Earth is not flat on larger scales. Looking at a galaxy is not like looking at a cat in the yard. You are seeing various measures of time and distance when you see a galaxy. You are seeing various speeds of light as well. Please make a note of it, and thank you for reading this little book of mine. References.
All right, here we go. That's it. This is the latest draft. It's probably going to be permanent, but I think it's pretty good. And if anybody has any comments, please share them. And also, please share and subscribe if you would like. And this is a message that needs to get out. It's going to get out sooner or later. You know, creationists are already talking about it. They just don't have the change in the measure of time plus the measure of distance, which compounds the effect of the change of the speed of light. But they'll get around to it sooner or later, I'm sure. So God bless everyone, and take care. And I'll see you soon, hopefully. God bless. Stay true, stay close to God.